Hello, this is Saeed. Hope you are doing well. Today we are going to discuss polarization. It is actually new addition in your syllabus. Polarization is very simple. It is not difficult. Here we will discuss some basic concepts, and after that we will go to solve some past paper problems. Okay, let's start. Polarization is actually a phenomena in which we restrict the vibration of the transverse waves in one plane, in one direction. For example, if we have a slinky spring like this one, and we put a filter in its path like this one, this filter is also called polarized, and these transverse waves are passing through it. But if we put the polaroid in this way, like in this way, then no waves can pass through it. So these are restricted. Means this transverse wave can travel in one plane, and if we rotate the plane at angle of 90 degree, the transverse waves cannot go through it. It means we can polarize these transverse waves. We can polarize, but if we have sound waves, like the waves consist of compressions and refractions, means the longitudinal one, and in its path we have again a polaroid here, means a filter after passing through it, and again we have a polaroid in the other way at angle of 90 degree. Then doesn't matter, it can go through it. Means we cannot restrict its path in one plane. Means we cannot polarize the longitudinal waves, but we can polarize the transverse waves. And the basic example of the transverse wave is the electromagnetic waves, means the light. Look at here. This is actually the symbolic representation of unpolarized wave, the wave which is traveling in all planes. So we have multiple planes here, like 1, 2, 3, and 4 planes. And if we put a polaroid in front of it and only one plane is allowed to move on, means the direction of the displacement of the particle is restricted in this way. This is called a vertical polarization. Uh, from this diagram, we can go for the definition of the polarization. Means if the wave is traveling in one plane and it is perpendicular to the direction of propagation, then it is called polarization. On the next slide, we have its definition again. But here, um, if the wave is traveling in one plane only and it is perpendicular to the direction of the propagation, then it is called polarization. This is also polarization. Here again, this is a horizontal polarization. Moving forward, look at here. This is again the unpolarized light. We have a polarizer here, so this polarized light is passing through it, while all other, like this one and this one and this one, all these are restricted or banned while passing through it. So it means the light can travel in one plane. So this is a polarized light. And if we have another polarizer at angle of 90 degree, means this wave cannot go through it. It means it's restricted. It confirms that it is a plain polarized light. So on the look at here, the sound waves and the longitudinal cannot be polarized. They oscillate parallel to the direction of the travel. And we can polarize the transverse waves because these transverse waves can be restricted to one plane only by rotating this polarizer. Look at this animation. This animation is very clear. Here we have these three colors. and all these three colors are showing the different vectors of the electromagnetic waves. In electromagnetic waves, we have the electric vector, and we have the magnetic vector E, magnetic is B, and the wave is traveling in this way. It means all these three are perpendicular with each other. Here, these three are perpendicular with each other, but while passing through this polarizer, the wave which is parallel to these filters can go through it, and the waves which are not parallel to these filters are restricted, or you can say absorbed. Means this thing is used in front of unpolarized light to make it polarize. So this diagram is for the basic concept actually. Moving forward, look at here. This is actually the relation which can describe the intensity. This I naught is the maximum intensity, means the intensity of the wave before entering into the filter. For example, if we have a polarizer like this one, and initially if the intensity is I naught, then after passing through it, now the intensity is I. For example, it's like this one, and after passing through this filter, it has a little bit rotation in the vector, means the intensity is reduced. That intensity is the transmitted intensity. This I is called transmitted intensity, shown over here. This is the maximum intensity, means the intensity of the wave just before entering. Now look at this graph. Actually, this waveform is not the cosine wave because we have the square. So by making the square of all the values means the intensity is always positive. For example, at angle of 0 we can have the maximum intensity, that is incident, this one. And how this incident intensity varies, it depends upon the angle theta. So at angle of 90-degree, no intensity, as we saw in the previous slide, that when we rotate this polarizer at angle of 90, no light can pass through it, means the intensity becomes 0. And it's maximum at 180, and then it's 0 at 270, and so on. One more thing. For example, if we have a certain intensity at this point, for example, if we make a horizontal straight line like this one, it means all these angles, for example, at this angle, then at this angle, and at this angle. At all these four angles, we have the same intensity. So if you have a certain angle, um, if you have a certain intensity at a particular angle, then the same intensity can be obtained at different angles as well. So this graph will be helpful. On the next slide. Oh, this is the past paper question. This is interesting. Look at here. This is the maximum intensity, that is called I naught. And while passing through this polarizer, there's a rotation of 30-degree, and now the transmitted intensity is called I1. Clear? So if we write the relation, then I is equal to I naught cos square theta. So this I is called I1. This is called I naught cos square of 30. Then I1 over I naught is equal to cos square of 30. While using calculator, I have the answer, that is 0.75. So the answer is 0.75 without any unit, because it is the ratio between two intensities. Now this intensity I naught is also called, this I1 is also called I naught cos square of 30. And for this polarizer, this is the maximum intensity and this is the transmitted intensity. In next relation here, we have again I is equal to I naught cos square of theta. So from 30 to 90, now the rotation in the angle is in fact 60 degree. And this maximum intensity I naught is this one. So we may write it as I naught is I naught. Hopefully you are getting my point. This I naught is the maximum intensity for this polarizer. And this maximum intensity is also called I1, which is I naught cos square of 30. So I naught cos square of 30 is the value at this I naught. And this cos square of 60 is written as well. And this intensity is the transmitted intensity called I2. So I2 over I naught, and by solving this relation on the calculator, the answer is 0.19. 0.19. So the answer is 0.19 without any unit. Moving forward, now in this question we have to write two things. First one is the statement of the polarization. Statement of polarization means if the wave is traveling in one plane and it is perpendicular to the direction of propagation. Wave is traveling in one plane and it is perpendicular to the direction of propagation of the wave. Now, state why light waves can be plane polarized but sound cannot. In fact, light is transverse while the sound is longitudinal because light is transverse and sound is longitudinal wave. Moving forward for some other parts if we have. Okay, yes. Look at here. Here we have two filters. In these two filters, the two polarizing filters A and B are positioned so that their planes are parallel with each other and the perpendicular to the central axis line XY. Means these are perpendicular, like this one and this one. Now, transmission axis of the filter A is vertical and the transmission filter of B is horizontal. The unpolarized light of the single frequency is directed along XY from source. The light emitting from filter A is vertical and its intensity is I naught. Means here we can have the same intensity. For example, this type of a plane is obtained over here means the intensity is I naught. And now the intensity at this point is reduced to I naught by 4. This is given in the question on the next slide. Means the intensity is I naught incident and the transmitted is quarter of the I naught. So we have to describe this angle which is being obtained here. So you know that I is equal to I naught cos square of theta, it means this I is now written as I naught by 4. This is I naught cos square of theta, and here cos square of theta is 1 by 4, then cos theta is 1 by 2, so theta is 60 degree. It means this angle is 60 degree. And if we have to tell the total angle, then the total angle will always be from this main axis, means from this to this. Initially, the angle is 270 up to this point. And now if this angle is 60, then the total angle is 270 plus 60. So by adding this, the answer is 330 degree. These are the two parts shown on the next slide. I just solved it here just because of this diagram. So here the angle of rotation is 330 after solving all the things over there. Now in this part, explain without calculation why these two waves cannot form a stationary wave with the zero amplitude at its node. In fact, in these two waves, the amplitudes are not equal. If amplitudes are not equal, then by subtraction you cannot get zero. The amplitudes are not equal, so by subtraction we cannot get zero displacement for nodes. For example, to describe this thing, for example, if one of the amplitude is say 4 centimeter and the other amplitude is say 3 centimeter, so by the subtraction of these two we cannot get zero. That's why there is no formation of the nodes. Look at here, you have to determine in terms of a naught the maximum amplitude of the wave. For example, you know that I is equal to Ka square, the basic formula. For maximum amplitude, the intensity is maximum. But if this intensity is reduced to, just to look at the question here again. Yes. Okay. If this intensity is reduced to 1/4, means now the new intensity is I naught by 4, and this is K, and the new amplitude is A square. A square. So by dividing these two relations, we have A square K is equal to I naught by 4, and this above relation is A naught square K, and divided by I naught. So by the subtraction and taking under root, we have A by A naught is 1/2, that is 0.5. So A is equal to 0.5 of A naught. So now the amplitude is reduced to 0.5 of the amplitude, maximum amplitude. But to get the maximum amplitude of the wave, we have A naught plus half of this A naught. So now the maximum amplitude is 1.5 of A naught. It is 1.5 of A naught. It means when the intensity was I naught, the amplitude is A naught. And when intensity is reduced to quarter of the initial value, then the new amplitude is A. This amplitude is now zero point 0.5 of the initial amplitude. So the maximum amplitude is A naught plus this zero point 0.5 of A naught. Hence the answer is 1.5 A naught. Hopefully all these concepts and past paper questions will help you to get the better understanding. If you have any question to solve or any concept, please write in the comments and I will get back to you. Thank you very much and good luck.